Hi everyone, audience and judges. We're from Vietnam and we're here to present an IoT-based industry protection system. Due to the pandemic this year, we're unable to meet up as a group and therefore this is our best solution. As industrialization continues to grow every day, accidents and threats are among the risks involved in this industry. Many of you may know that many factories are still adopting the traditional human risk assessment, which is rather slow and inaccurate and could also lead to fatal accidents every year. Precautions are necessary due to the supply and demand at its peak in the 21st century, and for the aforementioned problems, we think our invention is a real game changer.
So, based on the industrial problems that we mentioned before, we have been coming up with some more than effective ideas to solve these issues. Now let's take a look to this device. This device serves three main functions. At first, we must create a system that can monitor light conditions and detect fire or gas leakage in order to readjust and alarm workers immediately. Next, the temperature and humidity are also monitored constantly thanks to this system, and then all the recorded data will be uploaded on an online server in order to improve customer experience. Let's move into the implementation process. This process is really simple, which consists of 4 steps. To begin with, we have to lay up a list of requirements such as stable operation, compact, energy saving, and minimizing errors. The second stage is drawing schematics and laying out the case, and the process continues with testing on the breadboard and 3D printing the case. Once the device is finished, it is truly tested before going into the operation.
By now, you're probably wondering what is inside our products. Well, let me walk you through each of its components right now. Now we have the sensors, first of all, and here's the sensors in the real products. This is the temperature and humidity sensor, and it would help to collect both temperature and humidity ambient in the environment. This model specifically uses I2C, or Inter-Integrated Circuits Communication Protocol, for data transmission. Next, we have the PIR, or the passive infrared sensor. This sensor would detect the electromagnetic radiation in the environment or of the objects in front of it specifically. And since during a fire, there's a high rate of infrared radiation emitted into the environment, therefore, this sensor would help to effectively detect fire in the working environment. Next, we have the light sensor, which operates similarly compared to the passive infrared sensor. However, it would be for measuring the light intensity in the working place and allow the employees to adjust it into a much more suitable level in order to save electricity as well as keep the employees' eyes healthy. Lastly, we have the gas sensor, and as you can tell by its name, it is used to detect inflammable gases as well as smoke. After the data is collected by these sensors, it would be directed into the Arduino Uno. We chose Arduino Uno as our main microcontroller because it is an open source electronic platform that is based on easy to use hardware and software. So in our system, after the data is sent to the Arduino Uno in form of analog voltage, it would be converted into understandable scales and be sent to 2 places. So first of all, we have the 16:2 LCD screen, which is placed right here in the real product, and this would allow the users to immediately visualize the data. Next is an online server called ThinkSpeak, and this ThinkSpeak would be sent via this model, which is called ESP8266. So this online server would help the users to collect the long-term data and allow the users to have a look at it once in a while to see if there's any anomaly in the system or not, and fix it in time. Last but not least, if there is any risk of danger detected by the system, the Arduino Uno would send signal to activate the fan and the lamp in order to help alarm and control the situation. However, since the fan has a motor in it, which may send back EMF, we do not connect it directly to the main circuit. However, we use a relay instead, and to protect the main circuits from any danger.
And finally, all of this would get us to this device, which is capable of monitoring the lighting conditions, which it could identify as a fire or a gas leakage if necessary to warn the workers. This device is also capable of monitoring the temperature as well as humidity. All of these factors would be monitored constantly. We highly prioritize the efficiency and the reliability of our device, as well as ensuring that the device is fairly compact, as well as aesthetically pleasing. We developed this device with hopes that it would improve the quality and the safety conditions inside of the factories for the workers. First off, this device is capable of operating constantly. Thus, it could decrease the amount of accidents happening inside of the factories and also ensuring worker safety. Second of all, when researching for this device, we paid a lot of attention on how to optimize the power consumption of this device to keep the operating cost really low. And as such, the operating cost of this device is much lower to the salary which would have been paid to a hired supervisor. If this device is put into mass production, the price per unit could be cut down to about a half. And with all of this money saved, the factory owners could now expand their networks and buy more safety equipment and buy more accurate measurements.
And lastly, it's part 7, future improvement. The prototype has currently met our initial requirement. But however, in the future, we are thinking of some possible future upgrades. The first one is creating an app on both the iOS and Android device for remote control, because as of now, the device is fully automated. Secondly, it's integrating a fire prevention system into the device in order to extinguish fires by activating the on-site water pumping system. Thirdly, it's making a case. The case is currently made of plastic and 3D printed parts. So in the future, we are thinking of making the case of stainless steel or transparent plastic with thin sheets of rubber inside of the casing in order to prevent the electronics inside from suffering from water damage. And lastly, it's streamlining the product so it will be more available to the masses. Thank you for listening to our group project.